Okay, for this first question, you need to know that 1 centimetre is the same as 1 metre on here. All right, and it's quite a nice question to start. It says he wants the shed to be at least 3 metres from the house. So that's where this 3 metres has come from here. At least 1 metre from the hedge. So that's where this 1 metre has come from here. And then exactly 2 metres from the flower bed. So 2 metres is down there. So wherever you've drawn it, it's got to be in this area, but it would have to be the top half of it, the top part of the shed would have to be anywhere along these line here, okay? So you could have just drawn this a little bit more left, but not down. For this next question, what gives it away this area? Well, it says here he wants to cover, so that should trigger, I need to find the area of the shed. But also it says that it's meters squared there. So again, you should know squared comes in the answer. So the area of this shed is what he needs to cover, which is obviously 3 times 4. So how have I found the area? I do length times width, 3 times 4. So you get 1 mark for that if you've got 12 meters squared. But then it says that it's 15 pounds for every meter squared we need. So you need to do 12 times 15, that's for your second mark, and then your third mark for the answer of 180 pounds. All right, nice easy one, guys. It's obviously a cuboid, but if you're a little bit unsure, process of elimination is clearly not a sphere or a cylinder or a cone because there's no circles. It'd be between these two. A cube is when it's all squares, okay? A cuboid is rectangles. Right, for this one, it may help you to draw a number line here. But ground floor tells you 0. There are 3 floors of underground parking, so that would obviously be -1, -2, -3. So what is the third one? Well, it's obviously going to be -3. Jen is at level 7. She travels down 9 floors, so effectively you're doing 7 take away 9. Or again, if you need to use your number line like I've done here, 7 down to 9, where does it end up? -2. Next one, Anna parks her car on the floor that is labelled level -1. In the lift, she travels up 10 floors to her apartment to collect her friend Brody, then she travels down 5 to Brody's apartment. What level is Brody's apartment? So we need to add on 10 to -1 and then back down to 5. Sorry, take off 5. So again, use this, -1, 10, back down, okay? Hopefully you can do it in your head though. -1 out of 10 is 9, 9 take away 5 takes you back down to 4. And as you can see, I've shown a little diagram here. So 1 mark if you've got to 9, 1 mark for 4. Okay. On this question here, it says Gwenda is sponsored a total of £3 for every mile that she walks per mile. She walks 90 miles. And then a local company will give her 40% of the total amount she receives from her family and friends. So first we need to start by finding out how much money she's going to make from walking the 90 miles. So that's 90 times 3. Okay, we could have done 90, add 90, add 90. Use Napier's bones if you need to. So you get 1 mark for that. It's £270. But now we've got to find 40% because it's saying they will give her 40% of whatever she receives from her family. So how do I find 40%? Well, I'll start by finding 10%. Okay, to find 10%, we divide by 10. So 270 divided by 10 is 27. Then I need another 1, 2, 3, 4 27s. Again, you could have done 27 times 4 in Napier's bones if you wanted. Doesn't really matter, but you get the answer of 40% equals £108. So how much will the company give her? £108. That's your third mark. Okay. Next one. Gwenda knows that 5 miles is approximately 8 kilometres. So they're really nice. They give you that. It just means 5 miles is pretty much the same as 8 kilometres in real life. 2 different ways of measuring. How many kilometres are in 90 miles? So a couple of ways you could have done this. All right, I've done 90 divided by 5 and then times my answer by 8, but I think it's probably easier to do it like this. 5 miles equals 8 kilometres, and we just want to get 5 up to 90. So maybe if you doubled it to 10 miles, that would be 16 kilometres. And then how many 10 miles would you need to get to 90? Well, 9 of them, you could just times by 9, and then do 16 times 9. Okay, whichever way you do it, doesn't really matter, but you could have just kept adding on 10 miles, 10 miles, 10 miles till 90, as long as you got the answer finally of 144. Okay, quite a bit of reading required on this one, guys. So let's just get our heads around it first. A local group is going to have a stall selling lemonade. Okay, so I've got rid of all that because that's just kind of set the scene. Let's get our heads around this. Each bottle of lemonade contains 1,000 ml, and it costs 90p. So I've just rewritten it as 1 bottle equals 1000 ml, or you could write is equal to 1 litre. Okay, just written that there as well, 1 litre. They're the same things. The group plans to buy enough to sell 300 cups. What we do know is 100 cups cost £4. So the obvious thing to do first is how many packs of 100 cups would you need to get 300? Well, obviously 3 of them. So what I'm going to do is 4 times 3, which is £12. Okay, so £12 for your first 2 marks. Next bit's a little bit trickier though. Each cup is going to have 200 millilitres, but we're having 300 of them. So I'm going to start by finding out if 300 cups are going to have 200 ml in every single one. I've got to do 300 times 200, which gives me the answer of 60,000. So it's loads of millilitres of lemonade. Okay, now there's a slight error in these workings here. I'm hoping you'll notice it before I tell you. 60,000 millilitres is what we need. One bottle only has 1,000 millilitres in it. So you can either now change this to litres, which is what I've gone on to do, or, well, not me, whoever's workings these were, or what you can do is just recognise if one bottle is 10,000, but we need 60,000, how many bottles would you need? And hopefully you now know it would be 60 bottles. But the error in the workings here is they have divided by 1,000 to change it to litres, which is fine. Don't mind you doing that. But as you can see, there's a slight error here. 60,000 divided by 1,000 should give you 60 litres, not 6. So slight error there. 1 bottle of lemonade equals 1,000 ml or 1 litre, which I already said. So regardless, whichever way you do it, I think this is a little bit long-winded, but you would need 60 bottles. Okay, like I said, the easiest way for me is 60,000 millilitres here, 1,000 ml in a bottle. What do you times 1,000 by to get to 60? Well, obviously 60,000 then 60. So if I now need 60 bottles, my answer here of 540p is going to be slightly wrong because it was 90p a bottle. It should actually be 10 times bigger, which means my answer is going to be £54, not £5.40. And then when I add on the £5.40, sorry, the £54 to the 12, it's going to give me the answer of £66. Okay, but quite nice here that the error was made because you can see how it does massively affect your answer. So if you did make that slight error there and then had a different answer at the bottom, you'd still get 5 out of the 6. Okay. Okay. For this question, you have to use your answer in the previous question. So in these workings, it's obviously going to be wrong now because the answer of £17.40 was wrong in the previous question. So the starting of it is going to be the same though. We sell 300 cups and we sell them for 50p each. So whichever way you do it, it's going to get you £150 you receive. Okay, easiest way is 3 times 5, put the zeros in. So £150, so that's okay. Now, the next part is obviously going to be wrong because my total sales of 150 take away material costs, which is what we had in our previous answer, isn't actually £17.40. It's actually £66. So if I know it's £66, then I've got to just take off 66 from 150 instead, which is going to leave me with £84 profit, not 132. Okay, so obviously in this question I would still get 3, even though this was wrong. The mark scheme does give you the 3 marks because your method here is correct and you've used the answer from the previous one. So if whatever you had in the previous answer on the previous question, sorry, you've taken that away from 150, you will still get 3 marks even though the number used there is wrong. All right, for this question, they give you a formula here. They say to calculate the temperature decrease, you would do 6 times by whatever the height is, then divide by 1,000. Okay, so now it says estimate. You see that's in bold. So if we know we're estimating, we're going to make these numbers a little bit easier for ourselves. So make it as easy as possible. So 945 is closer to 900 and 4,085 is closer to 4,000. Okay, then all I'm going to do is use my formula at the top. 6 times 900 divided by 1,000, 6 times 4,000 divided by 1,000. Okay, so let's have a look for Snowdon first then. 6 times 900, again, 6 times 9 is 54, put the 2 zeros in. And then 54 divided by 1,000, well 5,400 divided by 1,000 is going to be 5.4, okay? Divided by 100, it goes to 54, and you have to divide it once more to get to 5.4. Next question, Mount Kilimanjaro, 6 times 4,000, and then divide by 1,000. So 6 times 4,000, 6 times 4 is 24. Put the 3 zeros in, 24,000. Divided by 1,000, there's 3 zeros on the bottom, cross 3 zeros off the top. It's the same as doing 24 divided by 1, which is obviously 24 degrees, okay? 2 marks for getting the 5.4, 2 marks for getting the 24. Obviously, if you've tried to substitute into the formula and you've rounded correctly, you're going to get a mark each for both of them. Okay, I'm going to ignore the top bit. Again, that's just setting the scene. We got this bit of information here. For 1 kilogram, it's £8.60, and we don't know the cost of a kilogram here. So that's obviously what we're going to have to get to. Mr. Thomas buys 1/4 kilograms of strawberries and 1.5 kilograms of raspberries. He pays with £20 note, he gets £2.55 change. Okay, so there's a few different places you could have started, but the bit I want to start off is, well, if I know you bought 1/4 of that, because that's £8.60 for 1 kilogram, this is 1/4 he's bought, I'm going to find 1/4 of £8.60. So you could halve it twice like I've done here, or you could just divide by 4 on a bus stop, right? But for 1/4 of the strawberries, it's going to be £2.15, right? So you get marks just for getting to there, 2 marks, okay? Now, I'm now going to start to look at the cost of the raspberries. Well, what some of you may have done at the beginning is notice that if you've got £2.55 change from a £20 note, I'm assuming you would have taken this off. So £20 take away the £2.55 means the cost of all of it was £17.45. We already know the cost of strawberries was £2.15. So this is the cost of the strawberries and the raspberries. If I know this is the cost of both of them, I know the cost of the strawberries. I've got to take that off. Okay. So I've done £17.45, take away the £2.15, which gives me £15.30. So £15.30 is the cost of all of the raspberries, which was actually 1.5 kilograms. But we need the cost for 1 kilogram. So we know it's got to be slightly lower than £15.30. Now, loads of different ways you could do this. This was the trickiest part, though, is noticing that if this is the same as 1.5 is the same as 1,500 grams, and you've got to try and get this to a number which you can then get to 100. And if you divide it by 3, which was the easiest way to do it, it would give you 500 grams, because 3 500s are in 1,500. So in a bus stop, I've divided £15.30 by 3, which has given me £5.10. And then if I know 500 grams is £5.10, I doubled it to get £10.20 for 1 kilogram. So that last bit's really, really tricky, but I would expect you to be getting marks for finding 1/4 of the strawberries. Then I'd expect you to be taking off, or you could have done it before, the cost of the change from the £20, and eventually get into the £15.30. If you can only get to the £15.30 and then can't do the rest, that's fine, that still gets you 4 marks. Okay, for this question, guys, it's all on the next page, so we know we've got to use this information, so I'll just hide it from the top. Right, first one, what fraction of the height of the tallest sunflower is the height of the shortest sunflower? Well, let's find the height of the tallest and the shortest. The tallest is 80, the smallest is 30, so as a fraction, that's got to be 30 over 80, but 30 over 80 is simplified to 3 over 8, okay? Next one, what is the ratio of the number of sunflowers with heights less than 55 to the number of sunflowers with heights greater than 55? So I'm going to count all of them which are smaller than 55. So 55 will be across here. So 1, 2, 3, 4. 4 of them are less than 55. Let's count how many are bigger than 55. 1, 2, 3, 4. So as a ratio, that's written as 4 to 4. And 4 to 4 can be simplified to 1 to 1. Okay, lovely. So that's your answer. I'll get circle it. Next one, Dieter's friend Glyn also planted sunflower seeds. Glyn's tallest sunflower grew to the height of 24 inches. Is that taller or shorter than the tallest sunflower? You must show all your workings. So if you go back to here, it tells you that grow to heights of up to 90 centimetres, and 90 centimetres is equal to 36 inches. So we just need to find out now, using this conversion, or maybe one you already knew, what is the height of this one, the 80 centimetre one. So we can either change the 80 centimetres to inches, or we can change the 24 inches to centimetres, okay, if we wanted. So this is one way of doing it. If you remember off the top of your head, 1 inch is 2.5 centimetres. You can just do 2.5 times 24 centimetres to find out how big it is. So shorter. Or if you use this conversion up here, 90 is equal to 36. One way you could do it, 36 inches is equal to 90 centimetres. Or you could divide this by 3 to get it to 12 inches. And obviously 90 divided by 3 is 30 centimetres. And then how many 12 inches get you to 24 inches? Well, 2 of them. So you could double it, 24 inches, which is 60 centimetres. Okay, that's also a very easy way if you can remember the conversion. And whichever way you've done it, you've got to obviously convert either to centimetres, or you convert the other height to inches. And my answer is no, it is shorter than the tallest sunflower. Alan and Gareth went on holiday to France. The total cost of the holiday was £660. Alan's mother paid a third of the total cost. Treat for her, or for him rather. Alan and Gareth shared the remaining costs in the ratio 1 to 9. So we got to first find out what they paid. And the only way you can do that is if we take off a third. How do you find a third? You divide by 3. So this is me doing it in a bus stop. Ali's mother paid a third of the 660. So if Ali's mother paid that 220, 1 mark, what did they pay? Well, you've got to take it off. Okay? And then what they paid was actually 440. So that's what they paid. So you get a second mark for that there. Now, we know they shared it in the ratio 1 to 9. Oh, bless me. If they shared it in the ratio 1 to 9, we got to split it up into 10 parts. So what we've done here is Ali gets 1 part, Gareth gets the 1, 2, 3, 4 other 9. So in total, that's 10 parts. Whichever way you've done it, you may not have drawn a picture. I got to do 440 divided by 10. And each one of these parts is equal to £44. Okay, so we know that Ali's mother paid the 220. We found that at the beginning. Well, if Alid only had 1 part of the ratio, he only paid 44. And then Gareth is going to be 44 times 9, which I've done here. Or you could have taken 44 away from 440, which gives you £396. Okay, so obviously your final 2 marks are for Alid and Gareth. How could you explain, how could you check they're all correct? Well, ratio is really easy, guys. Just add them all up at the end. And these 3 numbers should equal back to 660. Okay, this one's a little bit tricky, guys, because this gives you kilograms. We know the maximum load is 20 kilograms, but then this here is all in grams. So you can either change all of these to kilograms by dividing by 1,000, but then you've got really small decimals. My advice would be change this bit here and this bit here to grams. So how many grams are in a kilogram? Well, 1,000. So times them both by 1,000. So if his weight luggage was 21.13, it's actually 2,113 grams, not kilograms, no, you wrote grams in. Okay, then for this one then, times that by 1,000. Sorry, I've missed a 0. It's going to be 20,000 grams. So let me just correct that there then. 21,130 grams is what his weighs. 20,000 is the cut off. So we're actually 1,130 grams over. Okay, that is what we're over. That's the easiest way to do it. So if that's what I'm over, we've got to remove 2 items now, which are have got to be slightly bigger than 1,130. So if I'm going to choose 2 of them, we know that the coat is obviously going to be We know the coat is obviously going to be one of them, okay? Because that's really close to 1,000, so 820. So then what can I add to my coat to get me as close to 1,130, but not that far over it? So the hat is going to be too small, okay? So it's now between the headphones, the book, and the jumper. The headphones, if I added on 300 to the 820, it's going to give me 1,120, so that's not quite big enough. So if I add on this, it would take me to 1,140. So then therefore the jumper would be the second thing I remove, okay? Okay, for this question, we've got the conversion graph here. We know that Alid is obviously going to change his pounds to euros. How much is this in euros for 90? So it's a little bit tricky because if you look at the graph, it only goes to 60. So you've got to find any number on this line now, on the bottom, which you can get to 90 really, really easily. So you could do 10, but then you'd have to times 11.4 by 9. You could do 30, because how many 30s would go to £90, or 3 of them? Or you could do 45, okay? Doesn't really matter. Whatever you want to do, but you've got to get up to 90 euros. Personally, I would do 30 because it tells you right there, £30 is 34.2. So then how many 30s go to 90? 3 of them. So if £30 equals 34.2 euros, all I got to do is times by 3, or you could have added in a column method 3 times, whatever's easiest for you. But your answer of 102.60 euros, okay? Your 1 mark if you've attempted to use that conversion. The next one, a meal costs £25. How much is this in euros? So 25 is on there, but you've got to be really careful now. That's 25. What's that in between there? Well, the easiest way to do to find out your scale is look at what it started off from here, because it goes from 0, so up to £11.40. So then you know it's going up. These little 5 squares is half of £11.40. Half of £11.40 is £5.70. So then this one here is going to be another £5.70 on top. So to get me to here, it's going to be £5.70 added on to the £22. So add on the 5 takes me to 27. Add on the 70 takes me to £28.50. Okay, which is my answer there. Again, 1 mark if you've tried to use a method. Second mark for £28.50. Okay, quite a nice one here. It says Gareth looked at the exchange rates of buying euros. Okay, so here they are, and it asks you just to complete the graph. Well, it already gives you these two and this one, so as you can see, it's quite nice to plot then. So all you have to do is carry that on, make sure this definitely is in line with the numbers which correlate at the top. Next one says, which is the modal group? Well, modal means most, so out of all of these, which are the biggest number? 33 was the frequency, so the group is this one here, 1.12 to 1.16. Okay, nice question to start. Consider this at the end. Okay, guys, my advice, this is a tricky scatter graph one, but whenever you see a diagram, just get used to the scale first, because you're going to need to know it. So if you can write numbers in the middle of them, like I'm doing there, do it. 3.25, 3.75. It's going to help your understanding. Same with here, I've done it up there. Right. First question then, you state the fuel economy, so that's this bit, of the car with the largest engine size. So we need the car now furthest right, which is quite clearly this one. So you can see I've drawn a line up and across, and that's just below 25, so it's got to be 24. It's going up in ones. Next one, state the engine size of the car with the fuel economy 42 miles. So now we're using this scale, 42 miles, there's 41, 42. I'll line across until I see it and down. Now this is why I told you to fill them out. 2.25, if that's 2, that's 2.25. I'm hoping you can see it's going up in 0.5s, so that would have to be 2.2, not 2.25. Okay, so 2.2 for that one. Right, next question is a little bit tricky. It says, calculate the mean. So I made a note at the top there, add and divide for the mean. I'm hoping you know that. Calculate the mean fuel economy of the 5 smallest engine sizes. So if I need the 5 smallest engine sizes, I need the 5 which are furthest left. So as you can see, we got 1, 2, 3, 4 up there, but your 5th one is not there. It's actually this one down here, because that, as you can see, if I just put my pen there, that one is smaller than that one up there. So you now need to write down the fuel economy of all of these. So where does that one go to? Well, that goes to 17. This one here goes to 48. This one here goes to 53, 55, and 51, 57. Okay. So I've written all them down there, and they are the numbers you need to add. So for 3 marks, I think this is a little bit harsh. So I'm going to add all them up, which gives me, just hide my answers. I add all them up, which gives me 235, and then I divide 235 by 5 because there were 5 cars, and it gives me 47 miles per gallon. Okay, so 1 mark if you attempted to find these numbers, then obviously your 2nd mark for trying to divide by 5, 3rd mark for your answer. Why is it not suitable? Why is this not suitable average for cars with engine sizes of less than 1.5 litres? Right, what do I mean here by an outlier? Well, it's not suitable because if you look at your graph, although these 4 were very similar, you had this one down here which was completely out on its own. It was way off, so it's not actually suitable. You can't use that data because of that one outlier or anomaly. Okay, draw a line of best fit. Well, I've already done that. Line of best fit, remember, has got to cut through half of them. So make sure once you count the dots after, it's roughly, or should be as close to, 50% on this side, 50% on that side. The scatter diagram is more reliable to estimate the fuel economy of cars with engine sizes less than 2.5 litres. And do you think Sean is correct? The correlation is stronger for cars less than 2.5. So let's have a look at what we mean by that. 2.5 is here. And then if you look to the left of it, 2.5, all of these, apart from this one, all of these are really, really close together. The second we go bigger than 2.5, it's a bit more of a spread of data. So is she correct? Well, yeah, because the correlation is fine, but you could have gone into more detail explaining what I just said then, okay? But you could just say there's a stronger correlation. Last but most certainly not the least, bearings. 3 things you need to remember. Number 1, you always measure from north. Number 2, you always go clockwise. And number 3, 3 digits in your answer. Remember those 3 things, we're almost there. Find the bearing of Reuben from. So because it's from Milton Haven, I know I need to go from here. This is where I'm starting. So I'm going to zoom right in and draw a straight line first to help me. You can see I've already done it, but I'll repeat it anyway. So I draw a straight line because that is where I need to turn and face if I want to be facing towards Reuben. Now, the first thing I said is we always measure from north. So that's got to be 0 degrees on your protractor. Second thing is we always go clockwise. Third thing is 3 digits, hence where the zeros come from. But let's double check. So I line up my protractor. As you can see, my 0 now goes straight through north. So I'm going to use the outside numbers because 0 is on the outside. Stop there. And where does my line take me through? Well, on here, it's 41 I've got maybe. So 40 is what I had here first time, but mine says, I'd say slightly just out, 41. So the answer of 0.40 would have to apply because there's got to be 3 digits in your answer. Okay, obviously you'd be allowed 2 one way or the other. So if you've got 38 up to 42, then that's fine. Next one, find the bearing of Swansea from Reuben. So it looks like this one could be incorrect because they've done the wrong place. So it's the bearing of Swansea from Reuben. So that's nice, so this one's incorrect. Now, we know we've got to measure clockwise, so we actually need all of this angle in green, which is a little bit tricky because the protractor only measures 180 degrees. So my advice would be to measure, personally, my advice would be to measure anti-clockwise. So I'll go the other way now, 0 at the top, and I'll have a look at where this line goes through, the green one. And this line goes through 160. Why am I looking at the inside numbers? Because 0 started on the inside. So 160. So if I know all of this is 160, to find out the other bit, okay, it's going to be 360 take away my 160 degrees, because all of it together has got to make a full circle. And if I take away the 160, that leaves me with, the rest of the angle, which would be then clockwise. So it's obviously 200 degrees, not 220.